Hi friends, welcome to answer. So today is the 79th episode in the physics series. So physics means in science exactly. So yeah, today it is physics. So today we're going to discuss about one of the most dangerous weapons of mass destruction, the one and only nuke. It's so powerful that it can wipe out at least half a city with just one explosion. Yes, it's more than megatons of TNT. So powerful. Yes. So first let's see the two main types of nukes or nuclear warheads. First, so there are two types. So nukes. Okay. There are two main types. Atomic and hydrogen. Yes, so there are two main types using the two different types of nuclear energy. Yes, like nuclear reactions. So atomic bombs use the one and only nuclear fission. Meanwhile, hydrogen bombs use nuclear fusion. So first let's just see a small summary of both of these types of reactions. So first let's take nuclear fission. So fission means just separating two different objects. That means one object into two different stuff. Yes, so let's take a nuclei of a very big object, like a very big nuclei. For example, let's take uranium. Yes, which is mainly used in nuclear fission experiments. Okay, so let's take a small nucleus of uranium. So uranium has a lot of these neutrons and protons, but this is just like a reference, not for scale, to show how many neutrons and protons are there. Okay, so do you know how this nuclear fission is started? So nuclear fission is just a small process. It's a chain reaction which is caused by one simple thing. So first, the main starting thing to start a nuclear fission reaction is one small neutron. If we throw this neutron at high speeds towards this nucleus, very high speeds in the atomic scale, this nucleus will split in two. Yeah, and like that. Okay, so again with these two separate nucleuses, some more neutrons will be sent out, causing the reaction to continuously happen. So these more neutrons may hit other nuclei as well, creating a chain reaction. Yes, so this is nuclear fission. But what is fusion? That's okay. Fusion, if you know anything about English and its vocabulary, you know that fusion means mixing, and that is very much true. So the main energy that we get is from the sun, and the sun does nuclear fusion itself. It's not nuclear fission. Nuclear fusion gives a lot more energy than its counterpart nuclear fission. Yes, we cannot easily recreate nuclear fusion on Earth itself, but nuclear fission is pretty more easier than nuclear fusion. Yes. So that's why we have nuclear fission power plants, not nuclear fusion power plants. Yes. So what happens in this process is, because of high heats and pressures, tritium and deuterium. Okay. So let's take two isotopes of hydrogen, tritium and deuterium. Tritium. Okay. So at high temperatures, they both will just meet themselves. And with high temperature and pressure, just like in our sun and many other stars, they turn into a helium nucleus. And this process continues on and on. So this the fusion which makes helium is the one which is used in hydrogen bombs. So now let's just see some of the designs. So again, in each of them there are two separate main designs. In the atomic one, there's the plutonium based, and uranium based. Meanwhile, in the hydrogen, there's a thermonuclear, TN, and then I will call it the orb because it is pretty much like an orb. Yes. So now let's just rub all of this to give some space. So first we are going to start with the platinum based model. So this was used in the Fat Man bomb which the USA dropped on Japan. On Nagasaki, not Hiroshima. That's the second one. Okay, so let's take the internal structure of Fat Man. Okay, so this was used on a later atomic bombs, not the first ones. Okay, so let's just give some space here. Now, everything blue here is plutonium. Remember that. Everything red here is some other explosives, like other chemical explosives. Not these super, like not uranium or plutonium, but other explosives. Yes, a bit more less powerful. So first we need to know one thing in nuclear physics that is known as supercriticality. So first the critical mass or a critical state. A critical state is achieved when an object has the minimum mass to start a chain reaction. And these plutonium cores, when the nuke is exploded, are supercritical. They have higher mass, higher pressure than when they are subcritical. That means less than critical mass. Yes. So every object in our entire existence, in the entire universe, has a critical point. But for most other objects, it's pretty high, very very high. Meanwhile, for many very unstable objects like uranium-238 and plutonium-235, it is pretty low compared to every other object. Even we have supercritical point, but it's so high, it's so unimaginably high. Yes. Okay. So what happens is at the point, so here there's a small gap, and then the remaining is all the chemical explosives. So supercriticality can also be achieved when an object is too dense, very very dense to be in fact. So these chemical explosives are detonated, creating this small plutonium orb to explode rapidly, creating a chain reaction which in turn is the nuclear explosion. It makes all the remaining nuclear remnants. Yes, so this is the first design. That means the second design produced, but yeah, the first design which we are explaining in this video. So next, let's go to the design of the one and only little boy. The first one which the USA dropped on Japan. Yes. Okay. So next, this one is a bit more thinner but a bit more longer. It looks like a fish, but don't be confused that it's not a fish. Okay. So it also has two main sectors. So here it is not polonium, but not plutonium, but uranium instead. So uranium is blue. Okay. Not just normal uranium, but uranium-235, a very unstable version of the normal uranium. Not 235, but 238, sorry. Okay. So there are two separate pieces of uranium here. Next. So the green will be any other objects, like the things pushing. So here in the back there will be a small beam. And then behind all of that, a lot of explosives. So what happens is these things are almost going to be supercritical, only if they hit each other. So there are chemical explosives here. So when those explosives are detonated, this big uranium thing will hit the other one very fast, making both of them supercritical, and boom, it explodes. Yes. So this is for the main atomic bombs designs. So but there are still hydrogen bombs. So hydrogen bombs are very more powerful compared to atomic bombs, and they are actually invented, but a bit less powerful than shown in many other sci-fi movies. Yes. Okay. So I'll just show the two of them quickly. Okay. So the first design, the sword bomb is also a very famous but still a hydrogen bomb itself. Okay. So there are two of them. One of them the orb. Okay. Here is the chemical things, the chemical bombs. Next, a small gap. Here there is some plutonium or uranium, especially plutonium. And in green here, it's not any other object but just deuterium and tritium, which will later turn into, helium when exploded. So in hydrogen bombs, two things need to happen. Nuclear fission, which will later activate nuclear fusion. So first the chemical explosion happens, boom. Then the nuclear fission will also happen, releasing a lot more energy compared to the TNT, which are the other chemical explosives. And then because of the nuclear fission's energy, nuclear fusion will also start to happen. And then boom, the bomb reaches supercriticality. Yes. So this is for this design, which I personally call it the orb. I think it's not actually called the orb. And last and final design, which is similar to the gun-like thing. Yes. So this is a nuke. Okay. So a big board here. So first here there will be some chemical explosives. A lot more chemical explosives than before. So this black is going to be other objects, like metal. Then plutonium again. Wait, this is not the color for that, right? Sorry. Okay, the plutonium thing, plutonium or uranium, they could be put in like a spike like this. And then a big region of more of the thing, more radioactive material here. And last and finally, here are the hydrogen isotopes, deuterium and tritium. So when this TNT explodes, it will, as I said before, it will push this plutonium or uranium into this other plutonium or uranium, making it supercritical. And that pressure and heat will also make this thing supercritical. That means, and make them fuse to make helium. Helium. Yes, so hydrogen turns into helium again, and again, like boom, another explosion happens. So yeah, this is for today about the designs and types of nukes. Bye.